So we've looked at energy already, and now we want to explore this concept of power. So for power, we can see we've got two different equations written down here, and both of these are divided by time. So both of the p's here are power, both of the t's are time, but you'll notice that the numerator on top of the fraction is different. And so over here we have energy transferred, and over here we have work done. And essentially these terms are interchangeable. When we have energy being transferred, we can say that work is being done, but you can use either in different situations. And so let's take a look at an example. But before we do that, let's actually put on some units. So the power is actually measured in watts usually, the time is in seconds, and the energy transferred or the work done is always in joules. Okay, so this is an energy, this is also a form of energy, and these obviously have the same units. That's seconds and that's watts. And what we can say about the units for power, it is given in watts, but essentially what we can say is that 1 watt is equal to 1 joule per second. So when you transfer 1 joule of energy per second, then that is the same as saying that you have a power of 1 watt. And to understand this a bit better, let's actually look at an example of two motors. So you have a motor here, let's say this motor is 50 watts, and over here you have a second motor, and we're going to say this motor is 100 watts. So you have two different motors of two different powers, and these motors are going to be used to pull a weight. So let's hang a weight off of this motor and hang a weight off of this motor, and both of these motors are going to have the same, going to be pulling the same weight. And let's give this a weight of 500 newtons. Okay, so both of these have the same weight, and they're going to be pulling it up through this same height. Okay, so this height we're going to say is 10 meters, and this height is 10 meters. Now to pull this weight up a height of 10 meters, it requires the same amount of energy. So this 500 newton weight up a height of 10 meters, it will be actually gain some gravitational potential energy. That's the energy that will be needed to lift it. So I'll leave that for you guys to work out in the comments. But essentially the idea is that with both motors, they need to transfer the same amount of energy. But the difference is that one has a power rating of double the other. So this 100 watt motor, because it's more powerful, the rate that it can transfer the energy is actually faster. It's twice as quick as the 50 watt motor. And what that means is that it's going to be able to pull this weight up in half the time. It's going to be twice as quick as pulling the weight up as the 50 watt motor. Okay, so that's an example of how power works, and it's all to do with how quickly you can transfer energy, even if the amount of energy transferred is the same. So let's have a quick quiz now. So pause the video, have a go, and then we'll go through the answers. So question 1, a crane lifts a 300 Newton weight through a height of 5 meters in 20 seconds. What is the power of the crane? So the first thing we want to do is work out how much energy is being transferred. And we can say that the 300 Newton weight, because it's lifted a height, we know that's going to be gravitational potential energy. And so we can work out the gravitational potential energy, and we can say remember the formula is m times g times by h. And so mg is basically the weight, so that's 300 newtons, and the h, or the height, is 5 meters. So what we can say here is this is equal to 300 multiplied by 5, which should give you an answer of 1500 joules of energy. And then we're told that this was lifted through that height in 20 seconds. And so we know from our equation, power equals the energy transferred or the work done divided by the time. And so the energy transferred was 1500 joules. And we want to divide that by the time taken of 20 seconds. And so you should get a total answer of 75 watts. Or you could also put 75 joules per second, and both of those would be correct. Cool. The next part of the question then, or question 2, a second crane lifts the same weight through the same height in 40 seconds. What's the power of the second crane? And essentially what we've done is we've doubled the time taken, and so we know that the power essentially is going to be halved. And so if the power of the first crane was 75 watts, the power of the second crane will be equal to 75 divided by 2, because the time taken was double. And so 75 over 2, you should get 37.5 watts. And again, you can write 37.5 watts or 37.5 joules per second. Okay, so hopefully you got that one correct, and I'll see you in the next video.